I'll just share my screen. So there's the notes. Can you see the notes?
Yeah.
So again, I'm just going to do this each week, just throw down a few abbreviations that come to my mind, because you're going to see these things over and over, and it's good to become familiar with these things. Obviously, HVAC, we've talked about that every week, but supply air grill, quite often called it SAG, return air grill, RAG, and so on. Door grill is a DG. A door grill is used, it's a grill that goes in a door, obviously. It's used for relief air. So if you want to relieve air out of an office, for instance, back to an open space, or if you want to allow air to come into say a bathroom area, it can come in through a door grill and then be exhausted out through a grill. CHB is a cushion head box, and I'll talk a bit more about that later. And some other terms there that you're probably already familiar with. So ducted air conditioning, I'll just highlight that. And ventilation systems comprise ductwork and fans, which we've been talking about, to distribute or extract air from the various spaces and the areas served. The air typically enters or leaves the spaces through air grills or outlets. So supply air grills are commonly called diffusers, but generally the general term is grills. You might see another term that is registers. It's not used much now, but it used to be a common term. A register is basically a grill with a damper on the back of it. So it's just more of a technical description, I suppose, but that's all it is if you see that term. When we've calculated the airflow rates required for each space, so you've done your ventilation calcs or your heat load calcs, you know how much air you have to supply to a space, whether it's a room or an office or a large open space. You can position the air grills or outlets to provide the most effective air distribution with due consideration to cost and client requirements. So generally you're working for contractors, so their first consideration is usually going to be cost. They've got a budget, they want to meet their budget or do better, so they're going to be concerned. They don't want to put too many grills in, and you don't want too many grills anyway. You just want the right amount to get good distribution. But sometimes the clients have requirements as well, so you need to be aware of that. As you said, Jordan, there's many different types of grills and louvers available with varying performance, style and cost. So as we go along, you'll learn more about these and which one is the most cost effective, but I'll try and give you some idea today. And actually, I did say to you that this session probably might have to go into another week, because I want to talk about louvers as well, but I don't want to cram too much in. So I think today we'll concentrate first on supply air grills or diffusers, and then we'll talk about return and exhaust, and then on to louvers. So we'll talk about supply air grills first. All air grills will create a pressure loss in the system. Last week we talked about fan static calcs. So you've got to consider within your index run, which is your worst case pathway for the air, you've got to include the grills. So there might be an outside air louver and a final grill where the air comes out into the space. These pressure losses have to be taken into account. So again, the NCC comes into play. Volume 1, Part J6D5 specifies maximum allowable pressure drops for grills and louvers, which we have to comply with. So I'll just show you that again. This is from the NCC, Volume 1. It's a very important document that you need to be familiar with. This is Section J, which is the energy efficiency part. If you look down at from number 4, ductwork components in the index run, down to J, supply air diffusers and grills must not exceed 40 pascals. exhaust grills must not exceed 30, transfer ducts, door grills must not exceed 12 pascals. There's also 4D, pressure drop across intake louvers must not exceed the higher of. For single stage louvers, 30 pascals, two stage louvers, 60 pascals, acoustic louvers, 50 pascals. So you need to be aware of those things, and you can put those figures into your static calcs. When you're doing the static calcs, it's quite common or quite often that you haven't even looked at selecting the grills yet. Yeah, the drawings haven't started, but you're having to do the fan static calculation so that the fans can be selected and ordered. So you've got to put a figure in there. And this is why in the fan static calculations, there's usually plug figures for these things. But bear in mind that they're going to be on the high side normally. So if you can put in the right data, it's beneficial because you'll get a more accurate calculation. So that's what I'm saying there. Rather than using the maximum allowable pressure drop in the fan static calcs, we can determine the actual pressure drop using grill suppliers' performance charts, and we can get a more accurate assessment. So I sent you a link to the shape air information, which is in your files, but I'm going to talk about that a bit more shortly, and how you can go in and actually look at the performance of these grills. So once you know what sort of grills you're going to use, the performance data is there in the shape air information. Now, that's not to say that the contractor is going to use shape air, because there's probably at least 5, 10 suppliers of grills that they can choose, and they'll all have their favourites, and they'll get the best deals from their favourites because they deal with them all the time. It's just the usual thing. But a grill is a grill. It's a grill. And so they're not going to change all that much. So you can use the shape air information to get a more accurate value of the pressure losses. Okay, so let's, the more common types of grills and louvers used are listed here. So for supply air, I'll just highlight this section. Now, are you familiar with the Coanda effect? Have you heard of that?
Yeah.
Right, so this is and you can Google this if you want to read a bit more about it, but it's the tendency of a jet of fluid emerging from an orifice, in our case from a grill, to follow an adjacent flat or curved surface. So a ceiling, if you've got a grill on the ceiling and you're pushing air out horizontally, and air in the room will be entrained. So you've already got room air at, say, 23, 24 degrees, and you're putting in supply air, which is in summertime, it's going to be, say, around 12 degrees. So you've got cold air being blown in, warmer air below it, and that warm air is pulled up by this Coanda effect. And so you get a mixing of air in the room, if that makes sense. And that helps to maintain good conditions in the space. And that's called induction. So this causes induction of room air and mixing with supply air. So the different types of diffusers, there's louver face diffusers. You can have 1, 2, 3 or 4-way supply. 4-way supply is the most common, but sometimes you might have 3 because you're forced to put a diffuser against or close to a wall. There's no point blowing the air straight at the wall because it's going to hit the wall and go straight down. So you could put you can block that 4th airway and make it a 3-way supply. So those louver face diffusers are the most common type, and I'll show you a picture of one of those. Well, here's a ceiling grid. So there's a louver face diffuser, a 4-way blow. They're probably the most common type, and it's in a ceiling grid. Usually the ceiling grid is 1200 by 600. The diffuser is 600 by 600 face and sits in half a tile, if you like. It doesn't show the tile. Well, no, there's no tiles there, but they're normally 1200 by 600, and the louver face is 600 by 600. Swirl diffusers. Have you seen any of these at all?
Yeah.
Yeah.
So these are, well, they've been around for probably close to 20 years now, but they're a relatively new thing on the scene, I suppose. And more common these days. They used to be quite expensive, but now I think they're still a little bit more expensive than louver face diffusers, but they provide enhanced mixing of the air, so better induction than a louver face diffuser, and they're more suitable for reduced airflows. So if you've got a variable volume system where the airflow can be reduced in accordance with the load in the room, then swirl diffusers work better to give you good induction. And you'll hear a term called dumping. So with VAV systems, when you reduce the airflows, because the air is cold and you haven't got that motive force to create induction coming out of the diffuser, or you've reduced that force, the air can just sort of drop out of the diffuser. And instead of giving good diffusion through the space, it's starting to just drop the cold air, and that can be uncomfortable for people sitting underneath it. Swirl diffusers handle this better because the air is swirling around as it comes out of the diffuser. It tends to stick to the ceiling better on lower airflows. So you get better induction and less dumping. So they're good for VAV systems, which are quite common. You can have round ceiling diffusers of all types to suit architectural requirements. You can get variable volume ceiling diffusers. They're not used all that often, but and they're quite expensive. They're, from my memory, one ceiling diffuser, one VAV ceiling diffuser used to be about $500. It's probably more now. Whereas a louver face diffuser may be $50. So there's a big difference. But some people want that. You can
a
have
VAV diffuser, is that with a damper?
It's got an automatically operated damper, which is controlled by your space temperature. So you can have two types. You can have electronic control, so that a space sensor through a BMS or control system can drive that damper, drive the damper blade up and down inside the diffuser. Or you can have a self-acting one, which has got a fluid bulb, which drives the damper based on the change in temperature of the air entering the space. So that's basically the two types, self-acting or driven by an electronic motor. Linear slot ceiling diffusers to suit architectural requirements. So architects like these, especially in public spaces like foyers, meeting rooms, where people sit there and might be looking at the ceiling and think it looks nice. Linear slot diffusers look nice, I guess, but again, they're expensive. They're difficult to install, and you've got to be careful with the heights that you put them at, because, and often the architects want to put them in, as I said, like a foyer, which might have a very high ceiling. Now in the cooling cycle, that's okay, because the air will find its way down anyway, because the cold air will drop. You will get a coander effect, but it will drop down, so you'll get some circulation of the air to get that colder air down to the space. But in the heating cycle, if you put a linear slot anything above about 4 meters, they just don't work, because the hot air comes out of the diffuser and stays up there. So the hot air in a heating cycle might be, say, 35 degrees. The room air is about 20, 21. So that hot air coming out of the diffuser tends to stay up at a high level, and you don't get much induction. So just be aware of those situations. And you need to explain to the architect that that's what's going to happen. And sometimes they'll say, I don't care, just put them in. And if that's what they want, as long as you let them know that there might be issues. Linear bar grills, usually mounted in a bulkhead or on a wall, commonly used in residential apartments. So we'll have a look at those. Sidewall grills mounted on a wall or on ductwork, can have single deflection or double deflection blades. You can also get curved faced type, which if you're doing a supermarket like a Woolworths or Coles where they have exposed ductwork, sometimes they have spiral duct, circular or even oval shaped. You can get curved face grills that fit onto that quite neatly to match the diameter of the ductwork. The ceiling mounted light troffer diffusers for use in commercial offices, not very common these days, but used to be very common, but they're still available. And they sit above the light fitting. So the light fitting takes up, say, a quarter of a ceiling tile, and the light troffer sits over the top of that and has slots which blow the air in opposite directions. So you get that coanda effect from that. But again, they're expensive and they're not very common now. And there's jet diffusers for mounting on walls or ceilings for high airflow in large open spaces.
You see that at the airport a lot.
Yep.
The big, check-in halls.
Yes, and I was just going to say exactly that. That an example would be an airport check-in area where you've got a whole wall of jet diffusers. So they mount them at various heights. Again, you've got to be a bit careful about how high they go. I can remember one airport I went to, actually it was Munich. They had jet diffusers and they must have been 10 metres above the floor, right along one wall. And, you know, I mean, I don't know how well they work at 10 metres high, but you just have to be careful in your selections. But some of those areas, the doors are opening and closing so often anyway, it's difficult to air condition those areas effectively because there's so much wind coming in, going out, air coming in, going out all the time. So in a perfect world, the doors would never open, but then it wouldn't be an airport, would it? So I'll just keep going. I'll skip over return air for a minute and go to selection criteria. I want to get through supply air first today. So the type of grill selected for a project will depend on several factors, such as architectural or client preferences or requirements. And this is quite common, that they'll want a particular type of grill to suit their design. Project budget. So you can advise your client or architect that they've selected a linear slot diffuser. You could say, well, look, if you use a louver face diffuser, you're going to save some money. They might say, I don't care. That's what I want for this project or for this particular area. Project type and air distribution requirements. So, for instance, auditoriums, museums, airports, these different special spaces may require specialised diffusers for aesthetic and or performance requirements. So big open spaces like the airport, check-in areas, you use jet diffusers quite often because they can blow the air a long way and try and get the air around all the spaces. Obviously, the airflow rates are important, allowable pressure drops, NCC section J that we mentioned before is the maximum. Sound levels are important, and the performance data will give you sound levels for the various airflow rates and the size of grills and the colour. Well, there's probably other things that I haven't thought of at this point, but there's some of the important things anyway. Usually the grills are white, but you can get different colours if somebody wants that. Now, supply air diffusers specific criteria, obviously the above criteria, airflow rates. Now the throw. The throw is the distance the air will travel from the diffuser before reaching a nominated terminal velocity. And in our industry, the usual accepted terminal velocity, as I've mentioned a bit further down, is 0.25 metres per second. Now, you're not going to measure that, but it's just the data is based on that. When they test the grills, that's what they base it on. So this enables us.
Sorry, Peter. So the
Yeah.
terminal velocity is just a way of defining sort of the boundary of the throw.
Correct. That's
Okay,
exactly
so
right.
it's that kind of like constant velocity, curve where the velocity is 0.25 meters per second. That will sort of be some, like on a topographical map. It's just like a contour.
Yeah, and that enables us to lay out the diffusers or to do the spacing of them. So, for instance, I haven't got any diagrams I can show you, but I think Philip's going to give you an exercise on this anyway. He's going to look at spacing out grills, and I'll talk a bit about that so you'll be ready for it. So let's say you've got a large space, and you've selected a grill which will throw the air 4 metres, let's say. And let's say it's 100 metres. It doesn't matter how big it is, but it's quite large. And so your grill throws the air 4 metres. So how far would it be to the next grill along the ceiling, would you say?
Like 8 meters?
Yeah. So each one's going to throw 4 metres. So they're going to meet. The throws are going to meet at a point where the air is going to start to drop. But because the velocity is only 0.25 metres per second, it really doesn't have any momentum at that point. So you're not going to get air rushing down at that point where they intersect. It's just going to sort of fuse into each other. And below the grills, you're going to get this induction going on. So you've got good air circulation in the space, and you haven't got dumping of air. An example that you may come across at some point is a very large department store, for instance, say a Myers store or something like that. Big clients like that have their own briefs on virtually everything. And Coles, Woolworths, they all have their own briefs. But they'll say, because the Myers department stores are such big open areas, when you do what they call a base building, before they start fitting it all out with all their different areas, it's just a big open box. And it might be 100 or 200 metres from one end to the other, or even more. And they will say that, just from memory, let's say they'll allow up to 450 litres per second per outlet, and the maximum spacing is, say, 10 metres. So that's criteria that you can use to select the grills and to place them. Before you even select the grills, you can place them on the ceiling because they've told you that's their requirement. So you're going to go for the minimum number of grills to satisfy those requirements. Does that make sense?
Yeah.
So you can lay them out and then you can go and select them. But if you don't have that, then you're going to select them on the same basis anyway to select the minimum amount of grills to suit a space. The sound levels obviously is important. The next size is basically at the top of the grill. You can't, I don't know if you can see it. Let's see if I can open this one. No. I'm having the same trouble I had last week. You're sharing your screen. Yeah, it's doing the same silly things. On top of the grill, you can see it's got a flange around it, but there's a square, what they call a neck, above that, which is where the duct connects on. It's basically the same as the duct connection size. So you need to select that because that will determine the the volume of the grill. So you can have a large one for the full size of the grill, or you can reduce it to reduce the airflow for the grill. Because in some cases, you might have 600 by 600 face grills, but you might only have relatively small airflows. Say in an office, for instance, they still want to have this size grill, but the airflow might only be a quarter of what it is for the big open space. So you'd use a smaller neck to give it less volume or less capacity.
So that looks like a, hard duct connection. Often isn't it, it would be like a flex duct into a round neck. Right?
Yeah, I'm not sure. It's a bit hard to see from this photo. I just looked this up this morning, but the box on top of there, it may be a hard duct or it might be a cushion head. I'm not really sure what it is. It's hard to tell, but I've got a picture of a cushion head, but I've got this annoying message on my screen again that's just blocking one of the. I'll just open it up and show you. I'll just have to go back to the file. So there's a cushion head box. Can you see that?
Yep.
So that box, that's what it looks like on the side there, and that's what it looks like sitting on top of that diffuser. So this one, you can get different types, but this one takes up the full back side of that flange area. So in the ceiling grid, that just sits straight down on top of the diffuser, and then the round spigot on the side, you put a flexible duct onto that. If you had a hard connection to the diffuser, then it would look basically the same, but without the spigot, and then that would connect to a solid duct running above it.
Yeah.
Now I don't know if you can imagine this, but on site, we'll go back to this other picture. It's not the best picture, but it's much easier to connect a supply air diffuser with a flexible duct than it is to use a solid duct, because you've run a solid duct. Say your solid duct is running in line with this grid. Then you've got to cut into that rigid duct and bring a rigid piece of duct down to sit exactly in the right position on top of that diffuser. Now, do you get the feeling that's not that easy to do? It's bloody hard. And it usually causes a lot of problems on site when you try to do that. So generally we don't do that. You put a cushion head box on top and connect the flex to it. And it's the same with where you can. Sometimes you can't do it with return air. If the return air volume is too high, you can't connect it with flexible ducts, because flexible ducts have a limit on how much air they can carry. Okay. So let's say you've got a return air grill of 2,000 litres a second. Then you'd need, say, 4 flexible ducts coming off the box on top of that grill to carry 500 litres a second each. And each of those flexible ducts, this is off the top of my head, so don't quote me, but just to give you an idea, each of those flexible ducts would have to be probably 500 millimetres diameter, internal diameter, plus insulation. So it's big flexible ducts, or you can have 6 smaller ones or 8 smaller ones, but then you've got flexible duct going everywhere. And you don't want too much flexible duct because it tends to get squashed. Okay, I'm getting off the track here a bit, but I'm just saying things as they come to mind, because these are the practical things to consider. So quite often when you get to a certain point, and you just have to judge it on the project, with the return air grill, you might have to have a solid connection because it's too much air to convey with flexible duct. I hope that makes sense.
Yeah.
Yeah.
Okay, so we were talking about next size. Well, pressure drop obviously is important. What sort of distribution pattern do you want? 1 to 4-way type or swirl type or round diffusers or whatever it may be. Terminal velocity required, as I said, normally 0.25, but I think you can select them at 0.5 as well. 0.25 is the normal standard. You can get different materials, aluminium, steel or plastic. Obviously plastic is the cheapest, but it looks cheap as well, and it's probably not as durable as the steel or aluminium. Steel or aluminium have to be painted, of course, and aluminium is lighter, so it's probably the most commonly used. And there's the cost. I've talked a bit about plenum boxes or cushion heads. Sometimes a cushion head box is called a plenum. Same thing. But plenums is a much more widely used term in our world. A plenum could be a big mixing box at the entrance to an air handling unit or a fan cool unit. That's a common way it could be on the supply air side. If you've got a fan cool unit blowing out of air blowing out of a fan cool unit, it goes into a plenum, which is just a box, an insulated box. And then from there, you might take flexible ducts off that to the outlets if it's in a small room. So plenum is a widely used term. So supply air grills, as I said, and return air grills generally require a plenum or cushion head box above or behind to enable the ductwork to be connected. Flexible ducts are preferred because they're more cost effective and make site installation much easier. If you go to site and you talk to a sheet metal worker on site, say, would you prefer to connect a grill with a flex or a solid duct? I know what his answer will be. And it's cheaper. Well, it's cheaper because it's easier on site. And if you can reduce, our job as engineers, when you're working with projects on site, is to try and think of ways that makes it easier for the guys on site. Because if it's easier for them, it's going to save money. Because they're expensive guys, and working on site is difficult. And the easier it is, the quicker they can do the job, and it works out cheaper. And cushion head boxes do provide some sound attenuation in most cases. So they're sort of soft. They've got either internal lining or the material itself is a insulating material, so they will absorb some sound. I've just made a comment here. It's common for exhaust grills to be installed without cushion head boxes, and the flexible or rigid duct is connected directly to the neck of the grill. And normally it's flexible duct again, connected onto the neck. So you can get a round neck on an exhaust grill, or you can get a round neck on any grill if you want to. You can get an adapter, which will go from the square grill to a round spigot, and you can connect it directly with a flexible duct.
So why is that commonly done for exhaust grills?
Because they're usually small, and it's much cheaper to do it that way. And you're not so concerned about the acoustic attenuation with an exhaust. Whereas return air, in an air conditioning system, you've got noise coming down the ductwork from the air handling unit or fan coil unit, and you want to get some attenuation. And they're usually bigger. The grills are bigger. So it's hard to have the space to get a flexible duct connected to the top of a grill and then turn it over in the ceiling. So there's a few factors. It's just the normal way it's done. In a house, if you've got a ducted air conditioning system in a house, which we don't do much of, but the supply air grills will be direct connected. They won't have cushion head boxes on them. That's pretty typical. But they usually use round diffusers in houses. So it's pretty easy just to bring a flex straight onto it. And it's cheap. I'm going to skip over Louvres at the moment. I'll just mention this bit here on supply air diffusers. They're positioned to deliver the required amount of supply air to the space in the most efficient and cost-effective manner. So I've been talking about that. In this process, consideration is given to the above criteria. Normally, we would select the minimum number of diffusers required to deliver the air with consideration of airflow, noise ratings, and pressure drop. So that's a bit of a summary of what I've been saying. A room, or say an office, might have only one diffuser, whereas a larger space might have many. And this is what I said before. In some projects, a department store like a Myers store or something, the client may specify the diffuser type and maximum allowable spacing between diffusers. This enables us to calculate and set out the minimum number of diffusers required and the airflow per diffuser. So before I go on to anything else there, I'm just going to go and have a look at the shape air. Did either of you have a chance to have a look at this?
No.
So this
Yeah,
is in
so-
your...
Yeah, I think we were instructed to make an account with Shape Air, but I didn't see any, like real selection tools on their website. Really just more, I
Okay.
think there was some technical data and promotional sort of material for
Yeah.
their products, but I haven't seen this folder, no.
Okay, well, you can see the file reference there. So this is in your files in the toolbox, and there's a number of sections here, but section 1 diffusers. So I'll just open this and I'll quickly go through it. So this is a curved blade diffuser. I didn't mention this one, but you'd use this probably in a residential job, or if you've got a small commercial development where you want to have air blowing in a two-way pattern, you can use this one. Now, on each of these pages, if you scroll down, it gives you dimensional data and the different patterns you can get with these diffusers. Okay, if you want to throw it in all directions, you can.
So
And then
that was a variable pitch blade grill, was it? Looks like from one of the schematics near the top. A few pages up. I think one page up from there. Or
Yeah,
two.
I don't know that you can move.
Can you scroll up? Keep scrolling up.
Some you can.
There, it looks like there.
Oh yes. Well, yeah, you can. Yes, definitely.
What actually controls that?
It's just manual.
Right. Okay. Right.
So it's like shuttle louvers you'd have at home, on your windows. You can move one and all of them move together. They would all move together. Oh, well,
Right.
I would think they would all move together.
So during commissioning, that would be something that's just configured after the installation.
Yeah.
And then usually left that way. Okay.
Yes, and people will fiddle with them too. If they're not happy with it, they'll get up there and fiddle with it, which may or may not help the situation. But yeah, we don't use these very often, but just they are available. And I'm just wanted to show you what's available at each of these pages or screens. So you can go down and look at the performance data. I'm not going to talk about this particular one because we don't use many of these, but so then you can go over here and just click onto the next page. And there's a round diffuser, which has got a few concentric rings on it to get a better coander effect by having, taking air from the middle and then from right in the middle, halfway, and then, try and get these are more of an architectural thing. We wouldn't use that. We wouldn't select these normally for a commercial job, but it's more maybe a residential job. They might want to look that sort of look, but not in a commercial office. And there's another style with a couple more vanes on it, blades. This is one with a plate in the middle. Those plates are normally adjustable. So you can see that middle section here. Sometimes that's on a threaded rod. So you can wind it up a bit and close it up to provide a dampering effect to alter the airflow. Another one. Now here's the ceiling diffuser. This is the most common that we would use. So, and you can see the airflow going out horizontally, creating induction. Now, performance data. So you can see in this data, I'm not going to go through it in detail because we'll run out of time, but so it gives you some options here: 4-way, 3-way, 2-way. You can even have 1-way, or you can blank the 3 parts off and just have it coming out one side. And that's pretty rare, but you might want to do that. So this first column here, neck size, width by height, which is basically, it's a square sitting on top of the diffuser. 150 by 150, 225 by 225, and so on. So 450 by 450 is the max you can have for this diffuser. And that'll give you the highest airflow possible. So you can see the highest airflow, if you go right across to the right here, in the blue line, 800 litres per second per diffuser. And it'll give you a throw of 5.6 to 8.3. Now that's quite a range, but somewhere in that range will allow you to work out the spacing. But the noise level there is an NR of 39. That's quite high. Are you guys familiar with acoustics? Have you studied acoustics at all?
Not really.
Not so much, no.
Well, just to give you a bit of an idea, if you have 2 sound sources that are the same noise, it will add 3 dB. Okay, so if you've got all these noise sources around each other, creating the same noise because you've got the same airflow, then your noise level is coming up and up and up. It's like, here's a bad example, but if you're in a group of people and everyone's talking, when everyone's talking, the sound level's going up and up and up and up. It's the same thing, that those noise levels keep adding together to make it very noisy. So that, you might use that selection for a very big open warehouse or something like that, where noise is not really a consideration. They're not worried about the noise. But in an occupied space, you'd normally be selecting a diffuser for an NR level of, NR means noise rating. For an office space, the maximum NR level is about 35 to 40 dB. But with consideration for other noise sources are going to increase the noise, we normally aim for about 25 to 30 NR when you're selecting a diffuser, so that you don't push the noise up too high. So yeah, so there's a few things you've got to look at. The throw, the throw is going to determine how many diffusers you need. Obviously, you've got to start with the airflow. What throw do you want? So let's take an average, say around 150 odd litres per second. For a 300 by 300 neck, you'll get up to 2.5 metre throw, but the noise level is less than 15. So that's probably not a very good selection. Let's have a look at a smaller one. 225 by 225. For 150 litres a second, you'll get a throw of up to about 3 metres, which is a bit better. And 25 dB, and so on. So that's the sort of process. Just to do a quick selection, you're looking at the airflow first. What sort of throw are you going to get, and what's the sound? Yeah.
So what's the workflow? I mean, say you've got a space that needs, I don't know, 2,000 litres per second.
Yep.
Either you can go with a few of these grills with a high airflow and then minimize the number of grills, maybe only 2 or 3, or you can use 8 or 10 grills with a lower airflow and lower noise level. Typically, I mean, what information feeds into that decision making?
Well, if it's an open space, and quite often we work on projects where, say, if it's a commercial space, initially it might be just one big open space, and you don't know what's going to happen when somebody actually moves in, because they might start to build offices and boardrooms and things like that. And I'll have to change everything. But if it's a big open space, you would just select the minimum number of grills you can. Maybe you'd space them initially at, say, 5 to 6 metres, and look for a selection that way. But bearing in mind that if that causes a problem with noise, you might need some more, or if you feel that it's too quiet, you might go less.
Right, you have to constrain some parameter. Either the airflow per grill can't exceed, certain limit, or the noise can't exceed a certain limit, or the spacing can't exceed a certain limit. But that will come from, like the client brief, or the contractor will say, look, we don't want to, exceed certain, I don't know, airflow per grill, or that information's got to be provided in the spec.
Yes, yeah, it may be provided. And if you do have a specification, it probably will be provided, that they will give you that information. So you need to look at the spec and be sure of whether or not they have given you that. If they haven't given it to you, then you'll go for the first thing you would look for probably is the least number of grills that you can use in the space without causing any noise problems. And well, that's probably the main thing. The least number of grills for the airflow and consideration of noise. If it's a big open space, that's how I would go about it.
Okay, thanks.
Is that okay?
Yep.
So I guess when you talk to Philip about doing this, he'll talk about the same things, and he might have a different approach. Look, don't quote me as being the authority on this subject. It's really, every project's different and people have different approaches, but they're the basic parameters anyway. So you can see there's all that data available to make a selection. And you'll find after a while this becomes second nature anyway. You look at a space, you say, oh, we're going to space them like this, and you can do it without a great deal of analysis of this data. So just going on, there's another plaque diffuser, and as I said, each one of these has got data below it. So once you click over there, you can look at that data for that particular type. This is the same diffuser that we just looked at, but it's steel. The other one was aluminium, but the performance will be pretty much the same, I would think. Disc valve grill, plastic sealing diffusers, commonly used in residential jobs, these types. And here's a variable air volume diffuser. So that square disc can move up and down, and it's driven. It's automatically driven by the control system for the project. It might be self-acting, or it might be an electronic control system. So it says here, electronic model compatible with most commonly used building management systems. So that one has got that driving motor. Now, going back here, there's a section here. Section 2 grills does have some sidewall grills. I'm just watching the time now because we're getting close to 10:30. I'll look at swirls, and we'll go in and just have a quick look at some of these. So a swirl diffuser, it's got all these slots, and the air comes out of the slots. You don't see many of this style, but you can get them. Some architects like this style. I guess we think they don't look that good, but some architects like it. The more common looking swirl diffuser would be something like that. Okay, it's the same sort of pattern. It's a whole lot of slots instead of being and you can see that the air is being directed in a circular motion. So it's causing the air coming out of the grill is swirling. That's what it's called, a swirl. It's going around in more of a circle, and that's tending to get more induction because air's going in 360 degrees. With a louver face diffuser, you're not really getting a 360-degree pattern because there's gaps in between on the corners. So the swirl does give better better air distribution. And again, here you've got all the dimensional data, performance data, but you'll find when you compare, and it tells you how to go through it, we won't do that now, but so then you've got these curves of performance for different models: pressure drop, airflow, velocity, neck size, and I think it tells you how to work out the throw somewhere. Anyway, you can have a look at that, but here's one that gives you the throw. So liters per second, throw here, neck size over here. So if you've got, say, 100 liters a second, you'll get 2 meter throw for a 350 diameter neck. So that's pretty easy to figure out. If you've got a smaller neck, then you'll get more of a throw, but you'll have to consider the noise. Generally, the throw from a swirl diffuser would be less than a four-way blow louver face diffuser. So a swirl diffuser is more expensive than a louver face, but you'll need more of them as well. You'll need more swirl diffusers to get the same air distribution. But the air distribution will be better. You get better induction. And as I said earlier, they work better for variable volume systems where the airflows are reduced and you don't get the dumping that you'll get with a louver face. So they're probably the main considerations there when you're looking at the comparison between the two.
And what's the turn down ratio?
Well, that's a good question. You'd have to look at each one on its merits. I couldn't really quote a figure, but
generally, what does it mean though?
Well, VAV box. Oh, what is the turn down ratio?
Yeah.
Well, it's basically the minimum flow. So if you're going to get, so if it's 50%, say, then that means half the airflow.
Of the maximum capacity.
Yeah. So if your design is 100 litres a second out of the diffuser, then if you've got a turn down ratio of 50%, it's 50 litres. With VAV boxes and with VAV systems in general, you can go down to about 40%. And with a swirl diffuser, that will work okay. The 40% turn down ratio will be okay. I wouldn't go any lower than that, generally speaking. But if you have a situation where you want to go lower, talk to the grill suppliers and get some performance data if it's not available, and just see. And then they can test them if they have to. You know, I've worked on a lot of jobs over the years where they do want to use a particular type of diffuser, and we've sort of said, well, we're not sure whether they're going to work. I did a museum in Sydney not that long ago, back in 2019, where we finished up using a very specialised diffuser. They are commercially available, but not used much. And we did CFD testing and all sorts of stuff. We had a CFD analysis done to prove that it would work. So that was quite a big process. But yeah, these things can be tested if necessary to see if it will suit a particular job. If you do a high-rise commercial job, high-rise office, it's not uncommon for them to want to test the diffusers. So they'll go to a laboratory like we used to use Vipac. I presume they're still around. They have testing rooms where they can test the throw, the noise, all of those things, and determine whether it's going to do the job. And yeah, I mentioned coffer type, not coffer. The boots that go over the light fittings, they always get tested to make sure they work. Because if you don't, you might get something that doesn't work, and you bought 5,000 of them and it doesn't work. So they need to test them. So that's another type of swirl diffuser, different face pattern. This one's got variable vanes. These are quite expensive, but you'll see some of these and very big ones we have high ceilings. Places like Bunnings sometimes use them. If it's an air-conditioned Bunnings, they might have something like that. But we used these in that museum, the same project. We had an exhibition hall, which was 8 metres high. The temperature restrictions were plus or minus 0.1 of a degree. Humidity, and I don't know whether you know how hard that is to achieve, but it's not easy. Humidity is even harder to achieve. They wanted plus or minus 2% relative humidity. So we had to get very, very good air distribution, and the controls were very expensive as well. But we used these types of diffusers, and they were self-acting. So if it was on a heating cycle, it would change the blades. If it was on a cooling cycle, they'd change again to get the airflow, to get the air down through the space. So on cooling, as I said before, it's not so critical because the cold air will come down. But in heating, to get hot air down from 8 metres and warm the space to plus or minus 1 degree, that's extremely difficult. So we use these self-acting diffusers, and they worked. Thank goodness. Otherwise, the museum would have been in strife, because the exhibition hall was a place where they bring in exhibitions from overseas. And if they can't achieve, and they have to record the temperature and humidity, and if they can't achieve it or they can't maintain it, then they take all their stuff away. So it's big money involved in that. So sometimes you get those jobs that are very demanding, but there are solutions. We've sort of run out of time. Have you got any questions?
No.
No.
Has that been helpful?
Yeah.
Yeah.
I'm trying to. I don't want to. I want to give you some background on this stuff. You know, because you haven't been involved in the industry for long, I think it's good to have a bit of background, and that's what I'm trying to achieve without getting too technical. But because you're getting involved in the engineering and the drafting of these things, you need to know where to go. There's plenty of information available. You can find it and work your way through it. And you can just ask us if you need help. Just ask.
Sure.
All right. So next week we'll talk about the rest of this stuff. Oh no, it'll be the week after, I suppose. So next week it'll be duct work, and Philip wants me to talk to you about duct insulation as well. That's a pretty big topic as well. So I'm going to have to be see how I can refine it to 1 hour. It's more than an hour's discussion. I'll try and do it in an hour, but we might need 2 sessions for ductwork as well. So if we can't get through ductwork next week, I'll continue the following week with ductwork insulation and get that out of the way. Then we'll come back to grills.
Do you plan to do a session on dampers as well?
Yes, we will.
Yeah. Okay, great.
Yeah. But have you got a specific question or?
Yeah. But I might save it for when we talk about that, because you may answer it, and it's probably open a can of worms.
Yeah, okay. Yeah. If it's a longer discussion, leave it till then. If it can wait. If it can't, just call me sometime or talk to Ivan about it. Okay.
Yeah.
Well, I'll let you get back to it. Thanks for
Good.
your attendance, and it's good to have these interactive sessions, and just, whatever questions come up, just throw them at me.
Thanks very much, Peter.
Okay.
Have a good week.
Peter.
See you next week. Bye.
See ya. Bye.
Bye.